How's everybody doing today? Amazing. Amazingly. Everybody did their app. I don't have to kick anyone out. So, what? No, I don't have to kick anybody out. I checked. Right? So, with the magic powers. Okay, so for those of you who are online today, I have a new microphone that I got from IT. So if I need to up the volume or maybe turn it down slightly, the mic input, let me know. I can do that. Just type in the Twitch chat. Okay, so the task du jour is tic-tac-toe. Okay, so what kind of stuff do we need to do to make a tic-tac-toe game? We're going to go through, we didn't quite finish it last class, so I doubt we'll finish it today. Let me point out a few things that I've done in advance. The first is that I made some art. Okay, nothing special, fancy-wise. I've got a red X, a blue O, a sort of blank tile that's got a black border around it to be, the grid space that nobody's selected yet. And then I have this yellowish one that's meant to be like the selection cursor. Okay, so which tile are you sort of selecting? So it sits on top of all the other tiles, and we'll use that. Okay, so I just made that art in advance, no big deal there. And then block-wise, I've added just a few things so far. The first is that, well, I need to spawn 9 different tiles. Okay, it was kind of annoying copying and pasting all of that stuff, but whatever, I did it, okay? And then I needed to put them all into the correct position. That I do want to talk about as the numbers. Okay, good? All right, so, and I just made a function called MakeTiles that I call here on start just to kind of keep things cleaned up. And I set the background color to this sort of beigeish color. I make a cursor sprite of kind player, that's this little gold thing, and then I set its position to 80, 60, which is the middle of the screen. Okay, so it starts like this. Okay, and that's basically like all that I've done in advance. I went through and deleted everything we did in the last class so that we do it from scratch. Okay, so what things do we need to worry about to do tic-tac-toe? Yes? Go ahead. Huh? All right, you can win, and so we have to figure out how to check whether or not somebody's won. That will actually come to at the end. Okay? Right, so the turn issue, right, that one player gets the X's, the other player gets the O's. Okay? What else? Okay, when a tile gets selected, we need to switch it. And also, therefore, we need to make sure that it is able to be switched, right? So you can't flip an X or an O. You can only flip a blank tile. We'll have to worry about that. Yes?
Make sure you can't overlap the blank square that's already selected.
Okay. Yeah, you can. Well, okay, so the selection thing will be, right, how do I know which tile I'm selecting, or how do I select a tile in the first place? What else? Artie? Well, let's start with the cursor, the thing that I can move around to select which tile I'm on. Yeah, go ahead. Yeah, I've got to make sure that I move in such a way that I'm perfectly aligned with the grid. Okay, which means that I can't handle the movement the same way that I did with that we did with the video games. Okay, so in the sprite movement thing, right, there is, or maybe it's under controller, here it is. Move my sprite with buttons. Oops. Okay, and notice that it threw an error. Why is there an error there? there's no my sprite. What have I called it? I called it cursor sprite. Okay. All right, so I could do that. That's what we did, the controls for the spaceship game and for the platformer game. And that works, except, what's the problem? Yeah, it's not aligned with the grid, and in fact, I can go way the heck over there off the screen that is nowhere near the grid, okay? So that's not how I want to handle the movement. We'll have to do something else. Okay, so let me get rid of this block, okay? And then if I reset it, because I set the default position to be right in the middle, okay, now if I press the keys, nothing's happening because I haven't told it what to do. Okay, so if I'm not going to use the movement thing the same way that we did before, what else could I do? What other options? Yeah. Exactly. We can do on button press for what button presses? Right. Okay. So let's do left first. Right. It doesn't matter the order we do them in, but we've got to do 4 of these things. Right. Left, right, up, and down. And what happens in each situation is going to be different. Okay. But this will allow us to make the controls in such a way that we stay on the grid and we only move in increments of the grid rather than being able to sort of move freely like we could in the other games. Okay, now just quick bit of number crunching. I made the tiles here, or rather the sprites. They're all 32 by 32 units, okay, whatever. And the coordinate system, remember, how wide is the screen in units? Is remember? It's 160 units, pixels. How tall is it? It's 120, right? It's not square, right? Okay, so the middle of the screen is therefore where? At x equals 80, y equals 60, okay? And so that's why I set the cursor's initial position to 80, 60, because that's the middle of the screen. Okay, Gucci? Okay, now, if this thing is 32 units by 32 units, where is the square, let's say, directly to the left of the middle? What's its y-coordinate, first off? 60. That's easy because it's on the same row. What's its x-coordinate? That one's the one that involves arithmetic. I know, arithmetic is hard, but what operation are we going to do? 80 minus, which is 80 minus 32, 48. I know, math is real hard. Okay, so the x position of that tile to the left is 48, and then what would the one to the right be? $80 plus 32 is 112, okay? All right, now, what about the y-coordinates? What's the tile's y-coordinate that is here, where the mouse cursor is? All right, what math are we about to do? 60, and then the width is 32, so, huh? Yeah, they are. So 60 is the middle. Ah, you fell for the trap, Mr. Rogers. What's the trap? Yeah, you just gave me the y-coordinate of the bottom middle, not the top middle, right? Because just to keep us on our toes and require us to have coffee before we get to class, which way does the y-axis go? Down, not up, right? Just to keep these things interesting. Okay, so Artie for the clutch, 360 no scope. What's the y-coordinate of the top one there? 28, okay? And the bottom row would be 92. Okay, so when I created all the tiles, I did it in exactly that order, okay? And the other thing is I had to name all the tiles something, so I chose to do the top left is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I had to pick an ordering. That's just the one I chose, right? Obviously, any order could do, but once you make a choice, you have to stick with it. So, fine. Okay, so 2 questions we need to answer. How do I know that I'm allowed to move left? And if I am allowed to move left, how do I actually do it? Okay, so under what circumstances am I allowed to move left? Just say it in English. Yeah. Okay, but what about if I'm already on the left column? Huh? Okay. Keep talking. Okay. How do I know if there's an opening to the left or not? Right? So you guys have all said in English perfectly reasonable things, right? I want you to say that same thing, but in math.
Like if you go beyond these coordinates.
Then you can't move, or if you're within this range of coordinates, you can. Okay, so here's the way I'd like to think about it. What is the x-coordinate of this row or that row, the 2 right-hand columns? What's the x-coordinate of the middle column? 80. What about the other one? 112. Okay, great. So I can move left if my x-coordinate is 80 or bigger, because that means I'm currently either in the middle column or to the right of that. Okay? There I just found a mathematical expression that's equivalent to what you guys said. I can move if my x-coordinate is bigger than or equal to 80. Does that make sense? Okay, so that's what we're going to put in the on left button pressed event. We're going to say logic if, okay, then under logic I also need to make a comparison, so I need a numerical comparison. I want greater than or equal to, and I want 80. Oops. Okay, what do I want to compare to 80? Yeah. Yeah, the which sprite? Yeah, the yellow one. Okay, so I want the my sprite x, but it's not my sprite, it's cursor sprite's x coordinate. That's the thing I want to compare against the number. Okay, does that make sense? All right, now, if I am allowed to make a left move, what do I do? Okay, so this if thing is just checking, am I permitted to move? But it doesn't actually do the movement, yeah? I could, but if I do the velocity, I'll have the same problem that we started with, namely it'll be, right? What else could I do? Yeah, I can just change the position, okay? And sort of do it instantaneously. So what I can do is change cursor sprites x by minus 32. All right, why 32? Because that's the width of all the blocks, right? And obviously it could be different, but it's 32 here. Okay, so does that make sense? All right, so let's test it. Okay, so it worked. What's the problem now? I can't move in any of the other directions because I haven't told it how to, but also can I move left any further? No, okay, because what's my x position if I'm right there? Where it's not greater than or equal to 80. It's less than that, right? So that if statement is false, and therefore the change thing that's inside of it doesn't occur. Gucci? Okay, so now what do we need to do for all the other button presses? Same thing, but with some tweaks, okay? So I'm going to take this guy, and I'm going to duplicate him, and I'm going to do on right button pressed. Okay, what needs to change for the right arrow? Yes? Less than or equal to, but yeah. And then also, plus 32 or just 32, right? I don't have to specify the sign. Okay, why is it less than or equal to as opposed to just less than? Or for this one, I've got greater than or equal to. That was deliberate. Why? Yeah, exactly, because what's the x-coordinate of the center tile? 80, not 81 or something, right? Okay, so good. All right, so that gets me my left and right, and let's just test that real quick. Okay, looks like we're good there. Now what? Up and down. Okay, so what has to happen on up? Under what circumstances can we move up? Yes? Okay, got to do that. I don't care about the x-coordinates when I'm working with the vertical direction, so I'll change these to y. What else? Where's the middle of the screen in the y direction? Not 80, but rather 60. Okay, fine. What else? Yeah, I changed these to y, but am I moving in the correct direction along the y? If I hit up, what do I need to do to my y coordinate? Do I need to add 32 or subtract 32? Subtract, because, right, remember, up is down, okay? So that part's okay, but what about the inequality? Does it need to be greater than or equal to 60 or less than or equal to 60? Why? But I'd want to go negative direction if my y value is bigger than something, right? Bueller, it should be greater than. So the reason is, what's the y coordinate in the middle? What's the y coordinate underneath of it? Right, okay. So I want some to check whether or not I'm bigger than or equal to 60 if I can go up, right? Does that make sense? All right, now, similarly, what about moving down? Need to change both of these to y. Right, this needs to be 32, and this should therefore be less than or equal to. Okay, so you see how everything's kind of flippied? Okay, so now we should have everybody. Let's test it out. Gucci. Okay, movement's done. Now, if you were making, like, is anybody going to do like a Pokemon or Final Fantasy kind of sort of thing? Maybe? All right, so in Pokemon, what happens in Pokemon? Yeah. Yeah, so there's like when you go into battle mode, what happens? Okay, there's text like you have to talk trash against the other Poke whatever, Poke trainer. Now, what is it called in that? I don't have the lingo because I'm too old for Pokemon. Who do you fight in Pokemon? Wild Pokemon and other trainers. Okay, fine. So you're fighting a wild Pokemon, a wild something izzard, right, or whatever the names of these things are, appears. And then how do you fight them? Yeah, so you've got like attack, capture, runaway, right? In Final Fantasy, you've got like attack with your weapon, use magic, pick which spell, right? Blah, 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 right? So you got all of those different options, right? Well, depending on how you lay out your menu, it might only make sense to move up and down through your menu options. Maybe. It might make sense to move up and down and left and right. Well, we've kind of figured out how to do that. Okay, does that make sense? Yeah. So my point here is that what we've done here will also translate into, could translate into menu construction, right? It's a similar idea. Now, there is one other way to handle the button pressing, okay, which is there is this true-false block that I've got highlighted is a particular button being pressed that you could build into other functions, okay? And then with the drop-down, you can select whatever. You can also do left, right, or up-down only. You know, so if you want to just check the up and down or the left and right, you can do that too. Okay. Anyway, so we've got the movement handled. Okay, now what do we need to figure out? Yes? Right. Changing the tile's value. Okay, so what I decided to do, and this is the one thing that I didn't purposely delete from last time, is I decided that I would give a variable to each of the tiles called state. And by default, I'll make them all state 0, which I'm going to think of as being that they're blank. And then state 1, I'll associate with the first player picking it, which will be an X, and state 2 with the second player picking it, which will be an O. Okay? Now, but what I want to talk about before we get into the details, the weeds on that, is what's the difference between a local variable and a global variable? Yes? One level, one sprite, one object. Okay? A local variable is a variable that's contained within that object. Okay? An example of this would be the variable x. Well, there are lots of different x's, right? Each different object has its own x variable, even though they're all called x. Okay? So that's a variable that's associated with the object, this tile or that sprite or whatever, right? Okay. What local variables are built into vanilla MakeCode? Well, they are those guys all right there. X, Y, velocity, acceleration, friction, lifespan, height, and width. Those are all the ones that are built in by default. If I want to create a new one, how do I do that? Yeah, I want to, yes, okay, but if I go to the Variables tab, right, the red tab here, this allows me to create global variables, not local ones. Okay, now, in this case, could I have 9 global variables, tile 1 state, tile 2 state, tile 3 state, and so on? Could I do that? I could, totally. Do I want to? Probably not. Okay, because what about if I then came along and said, all right, your class project is to make 4x4 tic-tac-toe. It's not, but let's say I did that, right? Then you'd be like, oh crap, now I need 16 freaking variables like McKinney, you jerk. Okay. Yeah. So I want to avoid using global variables if I can, okay? The other reason that I wanted to use sort of something that's attached to the object is because that's how everything is in Unreal Engine, and so when we make the jump here in a few weeks, you guys will be like, oh, it's just like the local variables in MakeCode, it just looks a little different, okay? Gucci? Okay, so how do I create a local variable? Well, in order to do it, I have to load in an extension. And the extension I need is called Arcade Sprite Data. Okay? And then if I go to the Sprites menu and I scroll all the way down, some new stuff appears under Data, okay? Which will allow me to define object-oriented variables of whatever kind I want. Okay, now, you see there's a lot of things there in the menu. Okay, why are there all those things in the menu? What's the difference between all of them? Like, why do I need 12 things or whatever? Okay, elaborate maybe a little bit. Oh, the stuff that's under data. Okay, so forget about the image thing at the top. That's, yeah, so everything from data here down. Why do I need all those different things? Okay, well, these two are related, right? What kind of data are they both working with? Sprites as data. What about the two that are underneath that? Boolean. What about the two that are underneath that? String, then number, and then image. Okay, so the reason that there are all those different things is because there are different types of data that we could put inside an object. It could be numerical, it could be text, it could be an image, it could be another sprite within a sprite, right? So we could do spriteception if you want. And then the last one, Boolean. What the hell is a Boolean? Yeah, it's something that's either true or false only. It can only take those two states. Okay, it's called a Boolean because you don't know. It's named after a mathematician named George Boole, B-O-O-L-E, from the 19th century that did a bunch of work on logic and stuff like that. Okay, so we call these things Booleans or Booles after him. Okay, so a Boolean, though, is just can be true or false. So it's a single bit of data. That's the smallest unit of data you can have. Okay, numbers, strings, those are different data objects, and they're stored differently under the hood inside a computer. And actually, just quick poll. Future CS majors in the room? Handeth, raiseth. Oh, you guys are going to learn all about this in CS241, which, depending on what you take, are you guys going to do something this summer? Maybe? I know we talked and you are. Are you going to do? Maybe? Yeah, anyway. CS minors, anybody? Well, we got one right there. Yeah, future. You're only going to minor, Artie? Oh, what are you going to major in? Blech. All right, whatever. So point being, though, that like how these things are actually stored under the hood is complicated, but as Mr. Ramsey can attest from the architecture class, fortunately you don't have to worry about that. But what you do have to worry about is that numeric data and strings are not the same thing. Text and numbers are not the same kind of thing. Okay. Okay. So what I did was I defined for each of the different tiles a variable called state. And I set its initial value to 0. Okay. Now, to make all these tiles, I just copy-pasted everything 9 times. I probably could have done a loop and been smart about it, but I just did that just to be quick and dirty. Okay. Okay. Good on that. So now that I have a variable to encode the state of a block, we can then use that in something that makes the thing switch. Okay? Okay, so what do we want to do? Like, how do I know when to change a tile? Yes. When it's clicked on, okay, now I don't have the mouse, so it would be when I hit like A or B, say, and when my gold selection cursor is touching, or rather overlapping with, one of the given objects.
And also, you have to make sure that if there's some like X or O is really there, you can't change it again.
Yes. Okay, so I do have to worry about that also. Okay, so the first problem is I have to say, hey, who am I on right now? Okay, am I on this sprite? Am I on that sprite? Is it in state 0? If so, then I can change it. If not, then I can't change it. Okay, does that make sense? Okay, so let's see how we want to do this. So when you guys did the two games, right? So either the platformer or the space game. What are we basically checking? We need to know whether or not we're overlapping somebody. Okay? Yes? Okay. How do I know if I'm overlapping somebody? What did I go to figure that out? Yeah, on sprite of kind overlap. Okay, so that's where is that? I think it's in the sprite one, so let's find that, right? So we have here overlaps. On sprite of kind player overlaps other sprite of kind player. Do something. Okay. So that's what I'm going to use here to start. Okay, and let me scoochie this way over here. Okay, now, what are the two types of sprites that I want to be checking? Well, the player is the cursor, right? So what kind is he? What class? I called it just the player. I just left that as whatever, okay? But then the other type of object, in the game you had like food, projectile, enemy, and this is how you did something where like if you overlapped with an enemy, you died, but if you overlapped with a piece of food, you gained a health or something like that, and there were two different kinds of objects. Yes? Okay, so what kind do I want here? What kind or what class did I make all of the tiles? I called them class tile. Made sense. Yeah. Okay, so what happens if I overlap a tile? Well, by itself, nothing. Okay, because right now, am I overlapping a tile? Yeah, but I also want to do if I'm hitting a button. Okay, and so for that, let's go into logic, and let's go if what? Oops, wrong one. All right, let's use the A key, the A button. Okay, so what would this do? Under what circumstances would the thing on the, there's nothing on the middle there, but under what circumstances would something there get executed? Okay, that's what needs to get executed. But under what conditions would it get executed? Different question. I have to be overlapping and hitting the button before anything happens. Okay? Now, what happens? Keep talking. What do we have to check? Yeah, depending on whose turn it is. Okay? So what I need to do is say, if the button is pressed, I also need to check, well, under what circumstances am I allowed to flip the tile? Yes? If it hasn't already been flipped, okay? Now, numerically, how was I storing that information? Yeah, I had the value of that particular object's state variable, okay? So what I need to do is I need to check the value of that state variable, okay? So under sprites, I need to go down to item data as number, okay? And then under logic, I need to have a comparison, okay? And then I'm going to plop this guy in the first slot and then have a 0, okay? What data and what object, so this needs to go here. Okay, you'll notice there's a little warning mark. Why is there a warning mark there next to item? Whose item? What am I overlapping? Other sprite, so I need to put him in there. Okay, and then get rid of this dude. Okay. Data, what object or what data within the other sprite object? Well, that's the value, but what's the name? State. Okay, so the variable that's within this other object that I'm touching is its state variable. Okay? What is the value of its state variable? Well, I don't know, but what do I want it to be? I want it to be 0, because that means that I'm able to flip the tile. Okay, so what we need to put inside here is what happens if we are on a valid tile and hitting the button. Flips to whatever. Okay, well, whose turn is it? Do I know? Well, whose turn is it at the very beginning of the game? Yeah, player 1's turn. We'll call player 1 X. Okay, so what's this Q for, gentlemen? Let's make a new variable. And I actually already created it, so from the last class. So I'm going to set, not that one. Oh no, I want it under variables. I'll set initially when the game starts the player's turn to 1, because who gets to go first? Player 1. Okay? And then over here, what I want to do is I want to use an if-else. Okay? So, it is either player 1's turn or it is player 2's turn. Yes? Okay, so I need to say, is the value of player turn equal to 1? That is either true or false. Okay? If it's equal to 1, then I'm going to put everything in where my mouse cursor is. If it's equal to anything else, which would be 2 in this case, we'll put the stuff there. Okay, so if the player turn is 1, then what do I do to this tile? Change it to an X, change its state to 1, and change the player turn to 2. Okay, so 3 things. All right, so let's change the image. Okay, and so for that we would use this guy. Okay, and what am I going to change it to? I'm going to change it to the red X. What else do I need to do? Change the state and change the player's turn. So I'll set player turn to 2, and then under sprites, I need to go to set other sprites data, or not data, state to value 1.
When you type in state, does that matter? Does the computer by any means, or just
This, the word state, it does because that's how I defined it over here, right? They all have to match. Now, I could have 15 different things, so I could have state, health, power, ammo, whatever, okay? But the name is if so like let's say that I want to change the amount of ammo, and I make that change state by blah. Well, state and ammo are two different things, right?
So like, what's the difference between like state and variable?
State? Oh, okay. State is the name of the particular variable I created, right? But I could have just as easily have called it pickle, or yo mama, or, right, like its name is not relevant. It's just that whenever I refer to it, I have to refer to it by the same name, okay? And from a programmer standpoint, it's a good thing that I picked the name state, right? If I had picked the variable pickle as the name, is that particularly helpful to you? No, because you could be reading this code and be, pickle, what the hell does pickle have to do with it, right? Like, it doesn't make sense. So you want to pick a descriptive name that helps you in the process. Okay, does that make sense, though? Yeah. So the local variable, the particular one we're working with, is called state. And right now, there is only one local variable attached to each tile. It's state. There's no reason there couldn't be 12 other ones. It's just we haven't needed any yet. Okay. All right, so does that kind of make sense? Yeah? Okay, so those are all the things that we need to do if it's player 1's turn. What about if it had been player 2's turn instead? Then what? Yeah, we basically just need to copy and paste those things, set the player turn back to 1, set the state to 2, and set the image to not the X, but rather the O. Okay, does that make sense? Okay, so we should test this. A couple things should happen, right? First off, should I be able to flip a tile that's already been flipped? No. Okay, so let's make sure that that doesn't happen. Okay, so I just hit the A key, or space for A. And if I keep hitting it, nothing's happening. Right? But if I move to, what did I mess up? Yeah, what should I have changed here? Not sprite, but rather other sprite. Whoops. That was kind of cool, though. Okay. Okay, so that all works. Now what? Yeah. Like, I shouldn't have made it this far, right? Because I have reached it, before I even got here, I have reached a state where one of the players should have won. Okay? And in tic-tac-toe, right, what's the win condition? You get 3 in a row, okay? How many different ways are there that could happen? There's 2 correct answers to this. Okay, I said how many, so give me a number as the answer. Wrong data type. Okay, 8 is one valid answer. What would the other valid answer be? Oh, okay. So let's just worry about the win situation. Yes, you're correct. There could be a draw. We'll deal with that separately. Okay, so just the number of ways that winning could occur. 8 is a valid answer, okay? 16 would be the other valid answer, okay? And that depends on what we mean by a win, okay? Because there are 8 ways that player 1 could win. There are also 8 ways that player 2 could win, right? So the top row could be 3 X's or it could be 3 O's, okay? And similarly, middle row, bottom row, first, second, third column, and then the 2 diagonals. So that's where we got 8. And then because there's 2 players, it could 16, right? Okay. So how do we check that, let's just worry about the top row for right this instant. How could I check whether or not the top row has a win in it? What do I need to look at? Right. I have a win if all three of the state variables for the top row are the same number and none of them are 0. Okay, does that make sense? Right? If they're all the same, then that means that I have a win there. Okay? What about if they're all the same and they're a 1? Then that means that player 1 wins. Okay? If they're all the same and they're 2s, then player 2 wins. And if they're all the same and they're 0, well, it's not a draw yet, but we're still playing. Okay? Okay, so let's actually, I'm going to do, well, two things. One, I did this button pressing stuff differently with the other class. Okay, and I've deliberately done it differently with you than I did with them so that we could see both ways of doing it, or multiple ways of doing it. So the video from the last class and the project from the last class I shared up on the links on Canvas. So you can go see how we did it in the other case, right? Because maybe that other way made more sense. Okay, so I did the checking whether or not somebody won differently with them than I'm going to do with you guys. Okay, so let's say, well, first off, let's make a state for the game. Let's make a variable. Okay, and let me call this variable game state. Okay, and I need to set an initial value to it. So let's set it to 0. Okay, so let's say that we have the following states. 0 means the game is currently being played. 1 means that player 1 won. 2 means that player 2 won. And 3 means that there's a draw. Because that could happen, right? Okay, and we'll worry about the draw situation later because that'll take a little bit more work, but let's just worry about the winning situation, okay? So let me make a, let's make a function, okay? And let's make a function that checks, did player 1 win, okay? So let's say, what do we want to call this function? Yeah. Player 1 win, question mark. Okay? And then we get a define block, and so we can, let's make some room for it. This is why I don't like visual programming. Okay? Okay, now, oops. All right, so with the player 1 win, we can add parameters to this, okay, meaning does it take in numbers, but the other thing I can do is I can have it return a value. Okay, so I could have it return a game state, or I could just have it change the game state's value to something. We'll do that. Okay. All right, so how do I check whether or not player 1 wins? Under what circumstance does player 1 win? Yeah? Okay, all three of them are. So a row, a column, or one of the diagonals. Okay? So I have 8 different situations that I need to worry about. Okay? So let's just take the first row. What I would need to know for the first row, so I'm going to need one of these. Okay? So I'm going to need one of those as a blank. and I'm also going to need some logic, because we've said the word and a bunch, haven't we? Okay, so what do I need to check? Well, and I need to check the value comparison, right? So these are the three primitive pieces that I'm going to need to build a logical statement out of. Okay? I need to know the state of a particular tile, and I need to compare that against a number. What number do I want for player 1? 1. Okay? And so this number is what I need to compare to 0. Okay? Now, so let me duplicate this, and I'm going to duplicate that. What number? What item? And what variable within that? Well, what's the variable within it? That's easy. State, right? Which items do I need to check for the top row? Tile 1, tile 2, and tile 3. Okay? So tile 1, then I'll duplicate this. Tile 2, then I'll duplicate that. Oops. Tile 3. Oops. Yeah. Okay, and then I need all three of those things to be true. Okay, so I need to do several and blocks. So this would be tile 1 state is the same, and tile 2 are both a 1. And then, sorry, this gets a little bit messy. Okay, so that huge, horrible thing is saying, is it true that tile 1 state is 1, tile 2 state is 1, and tile 3 state is 1, all three of those? Okay, and if true, that means all three individually are true. Okay? All right, does that make sense? All right, so this, by the way, and I can get rid of this guy now. This, by the way, is, I hope you guys are now seeing one of the limitations of graphical programming, because that is kind of a mess, right? Let's go into Python mode. Well, first off, I have to put it inside an if block. Okay, so let me go into Python view, and let's sort of see what it looks like there. Okay, so def player 1 wins. Okay, if state is 1 and, right, and I could actually put parentheses in there to make it a little bit more obvious what the logical structure is. There turns out that when it's a bunch of ands, it doesn't matter where the parentheses are, because the whole thing's only going to be true if all individual things are true. Okay. When you start mixing ands and ors, then you have to worry about the parentheses. Okay, so it's not much better in text mode than it is in graphical mode, but maybe marginally better. Yeah? Huh? Well, okay. So let's go back to block mode. All right, and back over. Yeah. Okay, so this would check whether or not the first row has a win. Oh, did I mess that up? Yep, you're right. Thank you. That should be tile 3. Okay. Yes? Yeah. So what's the then if I have if this has happened? Yeah, I'd set the game state to 1, and that would mean player 1 won. Okay. Okay. So what I'll put on the inside there is just variables set game state to 1. Okay. Now, I'm going to make one minor edit here. because I'm going to be smart. I'm going to add a number. Okay? And I'm going to change the name to player win. Okay, because what about this code would change if I were checking it for player 2? The number. Okay, what am I checking if it's player 2 that wins? The game states are all 2 rather than 1, and what do I make the game state if player 2 wins? 2. So what I'm going to do is take this num, and I'm going to plop it in all of those places, and then I can recycle some code. Okay, so num, 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 and num. Okay, so then when I call this function, I could say player win of 1 would check whether or not player 1 won. And player win 2 would check whether or not player 2 won. And I can just use the function twice and only therefore have to write it once. Okay? All right, now, we still have more situations because this is only one of the 7 different possible, or 8, excuse me, possible ways that the first player, or that a player could have won. What are the other 7? Middle row, bottom row, first column, second column, third column, and the 2 diagonals. Okay, that's going to kind of suck to have to write all these, but what am I going to do? Essentially, I'm just duplicating this, what I have, 7 times, and then changing, instead of tile 1, 2, 3, maybe it's 4, 5, 6, 7, 8, 9, and so on. Okay, does that make sense? All right, so that part is just a bunch of copying and pasting. Okay, so I'll do duplicate, duplicate, duplicate. Then I'm going to select. So one thing I noticed is there's no way to duplicate. There's no way to select multiple blocks, which is really annoying. Okay, so I've got 5, 6, 7, 8. And let's get rid of this garbage. Okay, so what do I need to change here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that gets the 3 rows. Okay, and that's only because I chose to name them 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, all right, so now we're here, and we should do the 3 columns. So what are the 3 columns? 1, 4, and 7. Okay. And the second column is 2, 5, and 9. Or no, 8, sorry. Okay, and then the third column is 3, 6, and 9. Okay, so that gets the 3 columns, and then last is the diagonals. So what are those going to be? 1, 1, 5, 9. And then the other diagonal would be 3, 5, 7. Okay, so we got it. Okay, good? All right, so what we need to do then is all I've done is I've defined a function. But defining a function doesn't actually use the function. So I have to call the function somewhere in the game. Okay, where should I call it? A couple places I could call it. Okay, if I do it on start, That would work, but what's the problem with that? How many times would it execute? Only once. And right when the game starts, has anybody won? No. Huh? Yeah, I'd want to use either an on-game update or tie it to the button pressing business. And let me clean that up too. Okay, I could put it in either places. Okay, so let's go to game and let's look at on-game update. Okay, we could put it there. So why don't we put it here? Because that'll keep the button pressing business a little bit easier. Okay, so what do I need to do? I need to call the function player win twice. And pass the number 1 and 2 to it. So the first instance checks has player 1 won. The second instance checks whether player 2 has won. Okay, does that make sense? Okay, now, if player 1 has won, what should happen? Yeah, player 1 wins, we need to tell the user, okay? So that means logic, of course. I could put this here because it's not possible for player 1 and player 2 to win. That can never happen. So I'll go ahead and put that before I check whether player 2 has won, okay? So I could check, is it the case that game state is 1, okay? That would be the situation when game state, when the player 1 wins, okay? What should I do in that situation? Well, I could do a, well, I could do this. Splash, was that how it does the game, like, let's say, just say this. Okay. All right, let's run it and see what happens. All right, so I'm going to deliberately make player 1 win. Okay, player 1 wins. Okay, so what's happening? I'm stuck in a loop because what should I do to the game? Reset it, okay, and there is a reset game object. So I could splash that and then reset the game. And by the way, the reset doesn't occur until you hit A to get out of the dialog box. Okay, so, which is good, right? Okay, makes sense. Good? Okay, so what do we just need to do? Do the same deal if game state is 2. We could say player 2 wins. Okay, and then what's the last situation that we need to deal with? A draw. Okay, under what situation does a draw occur? None of them get 3 in a row, and here's the key, and the game's not over, right? So the game is not over if any of the tiles have their state at 0 still. That means that it hasn't been flipped yet, right? So the game is only over when all tiles have been flipped from state 0, okay? So let's make one more function for the draw checker. We made a function for player win. Let's make another function for is draw. Okay. All right. And what's the condition for a draw? Right. Okay. So we need to go through all 9 tiles and check whether or not their value is 0, 1, or 2. Okay? And then a draw would occur if all of their values are 1 or 2, which is to say none of their values are 0. Okay? Okay, so let's see, how do I want to do this? Okay, I'm going to make a temporary variable called okay, so here's what I want to do. I want to call, I'm going to say the number of available tiles, meaning the number of tiles that can be flipped, is starts at the number 9. Okay, I could put this inside the function. I could put it outside the function. I'll just put it here for now. And then what I'm going to do is I'm going to go through. Oh, that's not what I wanted. I wanted. No, it is under loops. Oh, no. What I want is hang on one second. Here it is. For element value of array of sprites of kind tile. This will get me a list of all 9 tile objects, and then I can go through and check, okay, if the all right, so let me just make it, and then I'll explain what I'm doing. Okay, so this thing, array of sprites of kind tile, generates a data object that has in it 9 tiles. For value in that thing, what that's going to do is it's going to go through all 9 of them and check something. Okay? What is it going to check? That's the if part. If the state variable is different from 0, that means that the tile has been picked. What should I do to the number of available tiles? Okay, so if I start with 9 available tiles and 1 has been picked, then I should take 1 away. Yeah, okay. So under variables, I'll go to change this by -1. Okay, so under what circumstances does a draw occur then if the number of available tiles is 0? Okay, does that make sense? Okay, so what I can do then is go back over here to my game update and make another if thing. If number of available tiles is 0, then that means that I have a draw situation. Okay, or what's the other thing I could do? I could say if game state equals 3. Okay, but we'll just use the available tiles. So if there are no available tiles, then I should splash draw and reset the game. Okay, make sense? All right, let's test it. Oh, oops. Okay. Oh, I know why. This. What's the initial value of available tiles? It's 0, so I need to set it to 9. Okay, now we should be good. Okay, so again, let me deliberately make a draw. Oh, why didn't that happen? We should be in a draw, shouldn't we? Okay, so let's see, what did we do? Huh, you're right, I never called it. Whoops, thanks. There we go. All right, let's try that again, shall we? You and being all smart. Player 2 should have won right there. All right, so why didn't that happen? It's possible, okay. State to 1. Well, okay, there's two possibilities. The first possibility is that I miscoded the back diagonal, because what is the back diagonal? 3, 5, and 7? Oh, no, that's right. Yes, this should have been there. It was nested. Okay, that was the problem. All right, so let's try again. Okay, player 1 wins on the back diagonal. That's fine. Draw. Okay, now I'm going to make player 2 win on the back diagonal. Okay. And now basically we just have to test all the different combinations. Okay. But hey, it works, right? We've got there's a game in an hour, 15 minutes. Okay, so what can we learn from all of this? Well, we've learned here, if you have a situation where you need like a menu, we had to basically roll our own menu, okay? In fact, one thing I'm going to do this afternoon, if I've got a little bit of time, is look into the documentation for this and see if it's possible for me to make my own extension. Because then I could make like a menu extension, for example. Wouldn't that be nice? Okay. I'm sure it's possible to make extensions, so I'll have to dig around and see what can be done there. Yeah, so we figured out how to handle movement for more of a menu style or something where it's discrete units. We've also therefore figured out how to, keep track of a game state. I mean, tic-tac-toe, nothing special there, right? The other reason, though, that this tic-tac-toe thing is kind of handy is because when we get to Unreal Engine, we're going to come back to this, and a lot of this code we can recycle, or at least the ideas behind it. Okay, some stuff we'll have to do differently, but yeah, okay. Does that kind of make sense? Yeah? All right, so let me save this and share it. So let's see, where's the share button? Share. Section. Huh? We will, but not yet. All right, so let me go in and here edit this. Okay, so I will post something for you guys to do on Canvas. So have a good rest of your day. See ya.